right now. Now, in the chapter of chemical equilibrium, you have to remember some terminologies, okay? Take it as if these are the basic definitions, okay? Now, over here, this sign is the reversible sign, okay? You should remember this forever, okay? Then over here, these are the match the column thing, okay? You should memorize these definitions by heart, okay? Alright, so reversible reaction is when the products can react together to form the reactant, and reactants are changed in the reaction, and products are formed in a reaction. And equilibrium is when the concentration does not change, or you can say it remains constant, okay? Alright, so please remember this terminology, that CC, okay, concentration will remain constant. And also equilibrium is one more definition, that the rate of forward reaction is equals to the rate of backward reaction. Got this? Okay. Then secondly, there is a word that is dynamic equilibrium, okay? Dynamic equilibrium means that something that is ongoing, okay? It's occurring at the same rate at the same time. Are you getting that? So continuously reactants are forming product, and continuously the products are forming the reactants, okay? They are breaking back into the reactants. Got it? Equilibrium over here, the reactant and products, okay, they're there because the rate of forward and backward is the same, and concentration and constant. And also it happens in the closed system, okay? If you dare to do equilibrium in an open system, all of the molecules will evaporate in the air and no use, okay? Then, okay, now this is extremely important slide, okay? Because over here this is talking about the color change as per the equilibrium shift, okay? Girls, you have to, and boys also, okay? So you guys have to remember this, okay? For equilibrium, that let's say if you will increase the temperature, okay, so the reaction will be favored towards the endothermic reaction, okay? What is the definition of endothermic reaction? The one that absorbs heat energy, okay? And let's say if you are increasing the pressure, okay, so the equilibrium will shift towards the side where there are less gaseous moles. Got this, everybody? Alright, now and then over here you have to remember, catalyst has no effect, okay? I repeat, catalyst has no effect, okay, as it only increases the rate of reaction. And if I add the catalyst, so the rate of reaction will be increased of both forward and backward. So overall there will be no change at all, okay? So now look at this example over here. Here, this is the equation, okay? Alright, the forward reaction is exo and the backward reaction is endo. Alright, now imagine if I am increasing the temperature, okay? So what will happen? The backward reaction is endothermic over here, right? Okay, so the reaction will shift backwards more, right? Okay, so you see the reaction is shifted backwards, okay? Why? Because it is endothermic reaction. How about yield? The yield is the amount of product formed, okay? So if the reaction is happening more backwards and less forward, okay, so that means the overall yield will increase or decrease? It will decrease. Are you all understanding that? Yeah? Okay. Now, what would be the color change? You see, the backward is brown, okay? Nitrogen dioxide is brown in color, okay? So that means it will become darker brown in color, okay? And now, let's say